Very good afternoon to all. I think last lecture we have started the performance parameters of boiler. Okay, and performance parameters of boiler, and in this regard, I think we have defined the performance parameters. Some of the important performance parameters of boiler. For example, evaporative capacity, then equivalent evaporation, then factor of evaporation and factor of evaporation. So equivalent evaporation, then I think boiler efficiency. This formula we have completed. So I think today we want to recap for 5 to 10 minutes. So who will define evaporative capacity? Evaporative capacity of a boiler. Who will define evaporative capacity of boiler? Fast, so that we have to solve the numericals. That day I have given note definition also. For somebody, or I have to tell names. Okay.
The quantity of steam generated by the boiler in kilojoule per hour or at full load condition is known as evaporative capacity.
Okay. So evaporative capacity can be expressed with respect to
Grade area,
with respect
volume
to
of furnace, and mass of fuel.
okay. If it is expressed in terms of great area, what will be the formula? What will
Total
be the
steam
formula?
generated in
Uh,
kg per hour divided by grade area.
Great area. Okay. And if it is defined with respect to the volume of furnace, K, total mass of steam generated in kg per hour divided by volume of furnace, and unit will be kg per hour divided by meter cube. Good. Now I think another somebody can define evaporative capacity with respect to mass of fuel burnt. Who will define other than Kunal? Somebody can take lead and come with definition. So this is very because uh, evaporative capacity with respect to great area and volume of furnace we are not going to use frequently because great area of the boiler is remaining constant throughout the life of the boiler, and furnace volume also we are not going to change throughout the life of boiler. Therefore generally evaporative capacity calculated on great area basis or volume of furnace basis remained constant, but mass of the fuel burnt vary time to time depending on our say application, depending on situation. We vary the mass of fuel burnt in the boiler or feeding of the fuel into the boiler. We are going to make variation in that because today I may burn 100 kilojoule of coal, but tomorrow I may burn 150. Day after tomorrow I may burn 50 kg. So depending on the requirement, etc., the mass of fuel burnt quantity will be varying, and therefore this quantity is very much important in the performance parameter. It is evaporative capacity with respect to mass of fuel burnt. Okay, and in that case, now who will define now other than Kunal? Fast. So evaporative capacity are denoting by ME. Only Kunal is responding. Others, fast, fast. We have to complete. We have to go for numericals. Then Sujit Mane. Sujit Mane, are you in lecture? Okay, Suhas, Suhas Naste.
Yes, sir.
You can define.
Evaporating capacity based on mass, it is defined as a ratio of total steam generated in boiler to the total mass of fuel burned in kg per hour.
Okay, it is in short we can say it as a ME is equal to what you can say
M
MS upon
M
MF.
M
Okay, then where MS is equal to mass of steam generated in kg per hour, and MF is what mass of
mass of
fuel
fuel burned
burnt in kg per hour.
in kg per hour.
Correct. Okay,
Yes.
so unit will be what kg per here kg of steam divided by kg of fuel. Okay, then second definition that they were completed is who will tell it is equivalent evaporation. Correct na? Equivalent evaporation. So we'll define equivalent evaporation now. Okay, I will define now. Equivalent evaporation means what? Here, if we want to compare the two boilers and having different operating conditions, for example, their boiler pressure is different, their saturation temperature is different, the feed water temperature of one boiler is different and another boiler is different. Then to compare the efficientness of two boilers, this equivalent evaporation term is used. And this means in any boiler, all boilers we are going to compare with a standard boiler. And that standard boiler pressure is 1 atmosphere. And definitely at 1 atmosphere, saturation temperature is 100 degrees Celsius. So we are supplying 100 degrees Celsius water to the boiler, okay, at 1 atmosphere, and we expect that 100 degrees Celsius steam should come out from the boiler. So means two your standard boiler is working at 1 atmospheric pressure and having temperature, having is converting steam at 100 degrees Celsius to 100 degree from 100 degrees Celsius water to 100 degrees Celsius steam, and therefore only the latent heat is going to be required. And this equivalent evaporation we are calculating or we are defining it as a the total heat required. So I'll write here total heat required, total heat, total heat, total heat required to evaporate feed water. So it is what defined as total heat required to evaporate feed water. Any temperature, any feed water divided by total heat required, total heat required to evaporate 100 degrees Celsius water to 100 degrees Celsius steam. And pressure is at 1 atmosphere pressure. Okay, so this is the definition and formula. Now who will tell me formula now? Total heat required to evaporate feed water, how much quantity of heat. So in that case, whatever the steam generated from the boiler, if it is HS, whatever feed water we are supplying to the boiler having enthalpy HW, then HS minus HW amount of water, amount of heat that water has taken in the boiler to evaporate in the form of steam, and therefore the formula will be ME evaporative capacity into HS minus HW divided by 2 will tell 2 somebody can reply 2 I told
57.
2257. What is this 2257? It is a latent heat of water at 1 atmosphere and at 100 degrees Celsius. Latent heat of water at 1 atmosphere and 100 degrees Celsius. Because we are supplying only 100 degrees Celsius feed water to the boiler. Okay. Only we are supplying 100 degrees Celsius feed water to the boiler, and we are here we are generating steam also at 100 degrees Celsius, and therefore it is required only latent heat. So ME into bracket HS minus HW divided by 2257 is the formula for equivalent evaporation. And what is the unit for this? Unit is what? Anybody? Unit? Anybody? Rishikesh Deshmukh, roll number 17. Rishikesh, kg of steam divided by anybody? Kg of fuel, correct? Because this is kilojoule per kg, this is kilojoule per kg. It will get cancelled unit. Only ME unit. The ME unit is what? Kg of steam divided by kg of fuel. So this is the only the unit of what? This equivalent evaporation. Then on that day, we also discussed about next parameter. So we'll tell factor of evaporation. In last third parameter we discussed is what? Factor of evaporation. Factor of evaporation. Who will tell factor of evaporation? Somebody have to tell factor of evaporation definition.
The factor HS minus HW divided by 2257 is called as factor of evaporation.
Okay, very good. HS minus HW divided by 2257. This factor is called as factor of evaporation. And what is the unit for this? Anybody?
No unit.
Sir.
No unit, because here also kilojoule per kg, it will get cancelled and it is having no unit. Okay, very nice. So equivalent evaporation, factor of evaporation is no unit, HS minus HW divided by 2257. Okay. Then fourth very much important parameter we discussed on that day is what? Boiler efficiency. Boiler efficiency. So ETA boiler. I will tell formula ETA boiler for boiler efficiency formula. First of all, we will define boiler efficiency. We'll define boiler efficiency. So, Sadashiv Bandgar, are you in class? Sachin Sutar?
Yes, sir. Yes, yes.
Boiler efficiency. Define boiler efficiency. Can you define? Sachin?
Yes.
Can you define
Yes,
boiler
sir.
efficiency? You can.
Yes,
Define first.
Total heat required to evaporate feed water divided by total heat supply to boiler.
Okay. What is formula now for this? It is the total heat required to evaporate fluid water is Ms into bracket Hs minus Hw, where Hs is specific enthalpy of steam generated from boiler. If it is wet steam, for we have to apply our equation, wet steam equation. If it is dry and saturated steam, we have to apply the equation related to dry and saturated steam. If it is superheated steam, we have to refer superheated steam table. Correspondingly, temperature and pressure we should know, and we can find out Hs. Hw is what? Feed water enthalpy. So deep temperature of feed water we know. So Hw is equal to Hf at given feed water temperature, and divided by how much total heat we are supplying for the boiler. If mf amount of fuel is burned in the boiler and having calorific value Cv. Okay. So then this ms upon mf we call it as a me into bracket hs minus hw divided by Cv, where Cv is calorific value of the fuel. I think up to that, I think up to this, we have completed on that lecture. Okay. Now we'll go directly to the examples now. Are you ready with steam tables, calculators?
Yes, sir.
Hello. Now I am back in lecture. Nothing due to internet problem. Okay. Now I think we have to. Yeah. Okay. Now I think visible this notebook.
Yes, sir.
Yeah. First problem we'll go for. I'll take problem from this and I'll solve on our PowerPoint worksheet. Okay. So first numerical. Okay. Formula we have written in short last lecture. Write down now. A boiler is working. A boiler is working at a pressure of 14 bar. Boiler is working at pressure of 14 bar. Evaporates 8 kg of water. Evaporates 8 kg of water per kg of coal from the feed water entering at 39 degrees Celsius. The steam at steam stop wall. The steam at steam stop wall is 0.95 dry. 0.95 dry. Determine equivalent evaporation for from and at 100 degrees Celsius. Right now also. Also find out. Also find out. Also find out the factor of evaporation. Also find out the factor of evaporation and boiler efficiency. Also find out the factor of evaporation and boiler efficiency. If coal is having calorific value 21,000 kilojoule per kg. 21,000 kilojoule per kg. Okay. Okay. So this numerical everybody written. Okay. Now we'll go to our worksheet.
Sir, problem not written.
Huh? Anything?
Sir, repeat problem. Sir, some part
काय झालं?
सर प्रॉब्लेम रिपीट करा एकदा.
रिपीट करू का?
प्रॉब्लेम लिहिलं.
काय काय केलं सांग. काय काय झालं तुमचं लिहून कुठपर्यंत मी आता तिकडं बरं ठीक
The steam at SSC is 0.95
ओके आय विल रिपीट ओके
dry.
okay boiler is working at if it is visible you can write only okay a boiler is working at a pressure of 14 bar. Boiler is working at a pressure of 14 bar. Evaporates 8 kg of water per kg of coal. Evaporates 8 kg of water per kg of coal from the feed water, from the feed FWD feed water entering at 39 degrees Celsius. The steam at steam stop wall, the steam at steam stop wall is 0.95 dry. Determine equivalent evaporation from and at 100 degrees Celsius. Determine equivalent evaporation from and at 100 degrees Celsius. Also find out. Also find out factor of evaporation. Also find out factor of evaporation and boiler efficiency. And boiler efficiency. If coal is having calorific value, also find factor of evaporation and boiler efficiency. If coal is having calorific value 21,000 kilojoule per kg. Now it is okay. Is okay. There should I then I have to go to that worksheet where I have to solve. Is it okay?
Yes, sir.
Or I have to repeat
Okay, sir.
again?
Yes, sir.
Okay. Now we'll now somebody have to read one by one sentence so that I will who will help me in this. First, what is the sentence? The boiler is, somebody can help me first because I am now on next second screen.
A boiler is working at a pressure
Okay, so
of
what is
14 bar.
given now? Steam pressure. So P is given as, write down, given data. So write down with me, given data. I will try my level best so that I will understand my handwriting. Okay. So pressure of the steam is given as what? Pressure is equal to 14 bar. bar. Then what is given next? Somebody? Pressure is 14 bar. Next. So what is dryness fraction of the steam?
Evaporates
So what is dryness fraction of the
0.95.
steam coming from the boiler now? What the steam is coming from the boiler? At steam stop wall, they got the condition of the steam. What is the boiler dryness fraction of that steam? Somebody can tell.
0.95.
0.95.
0.91. So x is equal to what? 0.95. So what is the steam is generated from boiler? What is quality? What is the quality of steam generated from the boiler? Type of steam?
Wait.
Wet steam,
Wet
because it is
steam.
dry inspection is less than 1 and in between 0 to 1. Okay, so steam is wet. Okay, then what is given now? Next, somebody can tell. Pressure is 14 bar, x is 0.95. Okay, and
Evaporative
this
capacity.
evaporative capacity is given. So what is given? Me is equal to mass of
8.
steam generated divided by mf. Write with me. Me is equal to ms divided by ml. What is the value is given? Anybody?
8.
Only direct value given as 8. What is unit for this? Kg of steam.
kg of steam
8
divided by
kg
kg
of
of coal.
steam. Divided by kg of coal. Now fuel or directly you can here it is given as coal, so you can write kg of coal or fuel. Okay, but fuel is coal we know here. Okay, so kg of steam divided by kg of fuel, it is 8. Anything is given now? And Me8 again, anything? So whatever the feed water is supplied to the boiler, so it is having what? So temperature of feed water supplied to the boiler. So generally, whatever the temperature for converting the water into steam, we are taking that water from atmosphere, and here it is going to be atmosphere temperature near about. Okay, a T feed water is equal to 39 degrees Celsius. All this for boil steam tables, all temperatures we need in degree Celsius. Okay, then anything is given now? calorific value is asked, correct na? Calorific value is given, correct? What is calorific value? 21,000 kilojoule per kg. Anything other than this is given? Anybody can help me? So this is given data. Okay. Anybody want to doubt about this? Shall we proceed? Shall we proceed? Somebody
Yes,
can?
sir.
Okay. Then what they asked, here I will write. What they asked to calculate. So they asked MA, equivalent
Equivalent
evaporation.
evaporation.
Equivalent evaporation MA, comma, factor of evaporation and eta boiler. So yeah, eta, I am writing eta BV, you write eta boiler. Okay. Then write down the formula of equivalent evaporation. Write down here equivalent evaporation. Equivalent evaporation. MA is equal to, who will tell? MA is equal to, anybody? Fast. ME.
MS upon MS.
Okay, but directly ME, shall I write ME into bracket? Continue. HS minus
HW.
HW divided by 2257. Latent heat of water at 100 degrees Celsius. Write down this formula. Equivalent evaporation ME is equal to ME is equal to ME into bracket HS minus HW divided by 2257. Then what is not knowing to us? HS and HW. I don't know where. HS is equal to, now who will tell HS value? Who will tell HS value? Somebody. Those are now steam table 2 part chapter 2 are completed. What is value of HS here? Who will tell? Kunal, Suhas, Gaurav, Ajit, Shingan, Shubham Shingan. Those I am remembering some names.
HF plus X into HFG.
HF, correct. HF, because steam is HF into
Wet
HF
steam.
plus X into HFG, because give that reason that steam is wet. It is not, because we define that steam is wet. And what is pressure of that steam? So this HF and HFG, from where we have to take? पहिलं न्यूमेरिकल आहे, सगळ्यांनी लक्ष द्या. हे न्यूमेरिक कुठून मिळणार आपल्याला HF आणि HFG? कोण आहे? कोणी सांगते? टेबल नंबर काय कुठून मिळणार आपल्याला? सांगा कोणतरी.
Table number 2.
म्हणजे स्टीम टेबल कुठून मिळणार? टेबल नंबर 2, जिथं प्रेशर दिलेलं असतं आणि त्याच्यानुसार आपण HF आणि HFG चे व्हॅल्यू काढतो. तर इथं लिहिलं वाटलं, तुम्ही लिहू शकता इथं 14 बार. HF आणि HFG कुठं रेकॉर्ड करायचं आपल्याला? 14 बार. Okay, where HS is equal to HF plus XHFG, कारण वेट स्टीम आहे म्हणून, and HF and HFG were to record at 14 bar. Okay, now from steam table, write down. Are you writing with me? In message or write yes. From steam table. This is numerically we understand. And definitely all kind of numericals are same variety. Only steam quality will be changed. Okay. Yes, sir. Okay. Then from steam table, from steam table. Which table Kunal told? Table number
2.
2. Where? Because where
2.
pressure is given. Table number from steam table, where table number 2. Okay. Now table number 2, we have to go for steam table now. Okay. And we have to go to the table. In that table, 14 bar pressure, and we have to note down HF and HFG. And then we can directly I will write HS is equal to. Everybody is having steam tables with you? Are you having steam tables with you? Somebody can tell. Okay. Chaneshwar Mishra, very good. HF is 830.1. Whether my help is required to give the values of steam table now? 830.1 plus 0.95 into HFG value is 1957. 1957.7. Okay. And then HS is coming as, somebody can tell HS value. Okay. Anybody is having problem, doubt how we are taking the value 830.1 and 157.7? आएगा problem? नसेल तर no म्हणा, so that I will get confident. Otherwise I have to show you how that this value Chaneshwar Mishra has taken. Anybody? If it is no, write down no fast. तेवढा 1-2 सेकंद जाऊ तुमचे, म्हणजे मला कळतंय. कोणाला प्रॉब्लेम नाही 830.1 हाऊ यू आर गेटिंग? गुड. नो अविनाश दादा, नो. गुड. Kunal. Okay, Kunal, now you got that answer for
HS.
HS. Okay. And HS is equal to what? 26 according 2689. 2689.91. Kunal and Shivani also got an answer. Good Shivani, good. But give the units. That is what? Kilojoule per kg. Okay. Then Parameshwar Patli, very 2689. Everybody getting 2689? Okay. Now next we have to calculate is HW. Then what is HW I have given? Anybody? What is the value of HW? It is feed water. It is only in liquid state. So HW will be only liquid. Where saturated liquid is there? HF only. Okay. So HW is equal to HF at which temperature is given? HF at feed water temperature. That is HF at 39 degrees Celsius. Okay. So HF at HW is equal to HF at 39 degrees Celsius. So म्हणजे पाणी जेव्हा आपण बॉयलर मध्ये सोडतोय तेव्हा त्याचं टेम्परेचर होतं 39. तर त्याची एन्थाल्पी किती असेल तर ते आपण कुठून काढणार आता? स्टीम टेबल वरून. अगेन हिअर ऑल्सो फ्रॉम स्टीम टेबल, राईट डाऊन फ्रॉम स्टीम टेबल. From steam table. From steam table. Okay. Which table? Now we will tell now. Table number
1.
1. Because why? Temperature is knowing. We are knowing only temperature. Table number 1. From steam table, table number 1. HW is equal to HF at 39 degrees Celsius. Will Kunal is giving answer. Okay, good. 163.3. I am taking on judgment, Kunal. Correct, na? You should write HW is equal to kilojoule per kg. Everybody getting direct? You are getting value. Or shall I open my steam table? Not necessary, na? So from steam table, table number 1, HW is equal to 163.3 kilojoule per kg. Okay, Shaneshwar Misra 163.32, correct, no problem. Are you getting? Now we got HS, we got HW, we know ME is equal to 8, we know 2257. And shall we calculate now equivalent evaporation now? Then equivalent evaporation what? Okay. So equivalent evaporation MA is equal to ME into HS minus HW divided by 2257 and is equal to ME is 8 into bracket. Here HS is how much? 2689.91 minus HW is 163.3 divided by 2257. Then how much it is coming? So it is Shivani Kunal got answer 8.955. Am I correct? What is unit? Unit also. Write down unit. Kg of team. Kg of team divided by kg of coal or kg of fuel. Okay. Then, okay, Pramod Avlikar, Gaurav Kondubhari, good. I'm happy. But all should write and in night way and they should solve. Shall I go to next parameter? Then, okay, Gaurav Karande, good. So, pointer, okay, sorry. Next is factor of evaporation. Factor of evaporation. We'll tell formula, factor of evaporation. Factor of evaporation, somebody help me.
HS minus HW upon 2257.
Okay. HS minus HS minus HW. So this factor is 2 to 5. Always the value will be always more than 1. Correct? Na? And how much we are getting now? HS minus HW is equal to 1.119. Which shall I write? 1.12 for me because my space is less. 1.119. I will consider it as a 1.12. Okay. So this is second answer. And next answer they asked is what? Anybody? Eta boiler. And is equal to, we'll tell formula. Will help me to write the formula. Anybody? Okay. So Babar is there? Nikita Babar, branch change the candidate. Babar, are you in lecture? Okay. Then Saurabh Pawar.
Yes, sir.
What is the formula?
Eta boiler is equal to MA into in bracket HS minus HW divided by calorific value.
Okay. ME, not MA. Yeah? It is calorific value. So all things you are knowing now. Okay, and is equal to 8 into HS is how much? So boiler efficiency is coming as 0.96. Hello, one change you do. So calorific you put it as a 35,000. I have given at my own, therefore efficiency is coming too much large. All are requested to in your notebook that make change in the question that calorific value should be CV is 35,000 kilojoule per kg. Make it change. Make the change. Calorific value 35,000 kilojoule per kg. And given data also you change accordingly. So 8 into HS. What is the value of HS? So HS value who will tell? Okay, I will. 2689 minus 163. I have given that a calorie value at my own, therefore efficiency is coming too much large. This is not the efficiency may comes in between 60 to 75%. And calorific value 3 lecture calorific value is what? Okay. Calorific value is how much? 35,000. You change accordingly in your question also, and then tell me the answer. 57%.
Sir, 57.
57% is the efficiency. Good, no problem. It should not be that much more. 96%. मग थोडा वेळ लागेल लेक्चर झाल्यानंतर काय चालतंय मग काय प्रॉब्लेम भोसले सरांनी सांगितले की मी करतो ते सगळ्या ह्याच्यावर भोसले सरांनी सांगितले की गोळे सरांनी मला लेक्चर चालू आहे चेक करायला सांगितलं हां त्यांना चेक करून सरांनी तुम्हाला चेक करायला सांगितलं मला रिस्पॉन्सिबल तुम्हाला धरणार आहे मला असं म्हणू बघ हॅलो इफिशियन्सी इज कमिंग ॲज नाही किंवा मला वेळ नाही 3 वाजता मग या मग 3 सव्वा 3च्या आसपास okay efficiency is coming as 57%. Suhas, Rakesh brother, but you change according to the value. Anybody having problem about understanding this numerical? Very simple numerical, only formula we should know, and how to extract the data from steam table that we should know, and if we, definitely we will not fail in solving the numerical. Shall we go for next numerical? Everybody understood first numerical? This numerical? I have taken a lot of time for this because this is a basic numerical. All numericals are based on this. Only, okay, so we should proceed for according to our students' suggestion. Okay, then so there also if equivalent to a percentage of steam. Okay. Then now next numerical. The boiler plant supplies. Numerically visible? Swaz, Kunal, Gaurav.
Yes,
Yes,
sir.
sir. Visible.
Okay. Boiler plant supplies. Boiler plant supplies 5400 kilojoule of kg of steam per hour. Boiler plant supplies 5400 kg of steam per hour at 7.5 bar and 0.98 dry from feed water at 41.5 degrees Celsius by using by using 670 kg of coal, 670 kg of coal per hour, 670 kg of coal per hour, having calorific value, having calorific value of 31,000, having calorific value of 31,000 kilojoule per kg, and calorific value 31,000 kilojoule per kg. Determine equivalent evaporation, determine equivalent evaporation, comma, factor of evaporation and boiler efficiency. Are you able to solve at your own? सगळ्यांनी घेतलं न्यूमेरिकल लिहून झालंय का सगळ्यांचं?
Yes, sir.
Okay, so write in message box yes, yes, at least. Okay, then shall we? Are you able to solve at your own? Okay. So Avinash Jadhav, Shubham Shangan, yes, they are telling yes. Okay, so I will also help in this. Now in this numerical, what is given data now? Who will help me? What is given? Somebody have to help me. What is given? Pressure of steam is given, correct? Na? The pressure of steam pressure is given data. Pressure is how much? What is pressure value? Pressure value, I think 7.5 bar,
bar.
correct? 7.5, correct? Na?
Yes, sir.
Okay, 7.5 bar. Okay, then the steam dryness fraction is given. What is the dryness fraction value is given? X is equal to
0.98.
0.98. Means what is this quality of steam? Again, if dryness fraction is there, then quality of steam is obviously what? Weight. So X is equal to 0.98 and steam is weight. Okay, then anything is given now. Temperature of feed water is given. Temperature of feed water. How much is the temperature of feed water? What is the value? How much? Anybody?
41.5 degrees Celsius.
How much? 41.
41.5.
41.5 degrees Celsius. Anything given? Other than calorific value is given, I think. 31,000.
MF is equal to 670.
Okay. Kilojoule per kg. MS, mass of steam generated is also given. How much mass of steam generated is given? Anybody? 640 or something.
54,000.
How much?
5400.
5400. 5400 or 540? 5400. Correct, na? Okay. Kilojoule per hour. So during 1 hour, this much amount of kilojoule, sorry, kg per hour. Kg per hour. And at the same time, how much coal were burning in the boiler is given?
670.
670 kilojoule per kg per hour, na?
kg per hour.
Okay. Both units should be same. Otherwise, then we can go for ME. Huh? It should be hour. If it is kg per day, here also it should be kg per day. Anything is given? Nothing, na? Okay. Now here, what they asked her to calculate? Equivalent evaporation, MA. Factor of evaporation, I will write here in short, factor of FE. Okay. And next they asked is eta boiler. Eta boiler. Then first formula, equivalent evaporation. We'll tell now. Equivalent evaporation. MA is equal to ME into, who will tell formula, ME into HS minus HW divided by 257. Okay, is equal to. Now we have to calculate HS. Correct formula, equivalent evaporation, MA is equal to ME into bracket HS minus HW divided by 2257. Okay. Now we have to calculate HS. Who will tell formula of HS? Now I will ask everybody. Yeah? I will ask. Then only your attendance will be considered. If you are not replying, then only your attendance considered. Otherwise, I will consider you as a absent. Rutuja Kapse. Are you in lecture?
Yes, sir.
Okay. HS. How to calculate HS
Yes,
now
sir.
in this case?
HF plus X into HFG.
Correct. HF plus X into HFG. HFX is knowing HF and HFG. Now for that, which table we have to refer? What pressure we have to calculate? So pressure is 7.5 bar. And therefore, and 7.5 bar. Now, okay, Rutuja, you tell the value of which table you will refer? Table number?
Second table.
Huh? Table number?
Second.
Second, okay. Table number 2. Okay. At 7.5 bar. Okay. HS is equal to, who will tell? Tell. Rutuja, Parmeshwar Patil is ready with answer, HS and HW. Rutuja, your answer, HF value at 7.5 bar. HS, are you audible? Rutuja Kapse.
Yes, sir.
HF and HF value tell at 7.5 bar. Table number 2 I have to refer. Okay, shall I help? So table number 2, where is steam table? Steam table. Table number 2 we have to go for. Those are new with now, they can go for, this is steam table. Okay, so this is table number 2. Table number 2, when pressure is given, we have to use this table number 2. Okay, then table 7.5 bar, if the pressure is available in the steam table, we have to check. 7.5 bar, value is not available in the steam table, HF and HFG directly. But what is there? 7.4 and 7.6 value is with us. Therefore, this value, HF is what? 706.9 and 711.7. Its average we have to go for. HFG also going to be average. Okay, then correct na? So 702 and 708. 704 is the value for this. Okay, and 2055 near about that value will be there HS. So our one of friend Parmeshwar Patil we got answer. So 2754. 2754. It is wrong, I think, Parmeshwar. Or it is pressure is only 7.5 bar, na? Pressure is 7.5 bar.
सर सर HS 3418.853 येते.
HS किती येतोय?
3418.853.
3-4 घेतलं पण ओके. टेबल नंबर 2 ॲव्हरेज काढायचा आणि HS इज इक्वल टू I will get टेबल नंबर 2 ॲव्हरेज काढायचा 7.4 आणि 7.6 ॲव्हरेज काढून HF लिहायचा. HF जी लिहायची. HF किती आहेत सांगताय मला कुणाल? डायरेक्ट केले तुम्ही?
सर HF 709.3.
ओके 70 पाटील
9.3.
709.3 करेक्ट ना? 709 ना करेक्ट ना? 0.3 प्लस
Yes sir.
0.98 into how much HFG is there? किती HFG?
Sir HFG 2764.
27
764.85.
0.8 at least I'll write 8. Okay, and HS is coming as finally
3418.
3 4 1
418.853.
kilojoule per kg. Okay, then HW. Now HW is equal to, what is the value of HW? Is equal to anybody?
173.7.
Okay, it is always equal to HF at feed water temperature. Now what is feed water temperature? 41.5 degrees Celsius. So HW is equal to HF at 41.5 degrees Celsius and is equal to, now for again this table number 2 we have to go for. Okay, table number 2. So Rakesh brother solved complete numerical. Good. So Prathamesh Patil, तुम्ही कसं काय चुकलं तुमचे आन्सर? फॉर HW इज इक्वल टू कुणाल
0.7.
173.7. टेबल नंबर 1 वी हैव टू रिफर, करेक्ट ना? 173.7 kilojoule per kg. Okay, then after getting HW, ME we know, therefore equivalent evaporation is coming as equivalent evaporation MA is equal to HS. Okay, put the values that we know. ME is equal to, already calculated na or not calculated? Okay, ME is equal to HS upon ME. Here you calculate ME value.
Sir, HFG value.
Calculated na or not calculated? Not calculated. Okay. ME is equal to what? 5400 ms.
Sir.
हाँ.
Sir, HFG value, sir.
HFG value चुकली.
हाँ, wrong है.
Wrong है. HFG चुकली.
Okay, HFG value किती आहे?
2055.33.
205.
Yes.
7.5 वर आहे ना प्रेशर?
That was 7.5.
Yes, sir.
ओके, मी इथे किती व्हॅल्यू करू? कुणाल
तिथं
चुकलाय का
नाही.
ते?
Yes, sir. 0.98 into.
एक मिनिट. 0.9 HFG पण चुकली का?
HFG चुकले सर.
तर ऍक्च्युअल मध्ये HFG व्हॅल्यू रॉंग आहे.
ऍक्च्युअल मध्ये काय व्हॅल्यू काय म्हणताय?
HFG ची
HFG
ऐवजी
व्हॅल्यू रॉंग आहे.
HFG.
एक जण सांगा कोणतं. HFG ची व्हॅल्यू किती आहे?
HFC का?
बरं HFG सांगा व्हॅल्यू मला कोणतं.
2055.
HFG किती?
2055.85.
2055 2055 पॉईंट.
2055. ती नाही 709.3 plus 0.98 into 2055.85.
नाही मला फक्त ते HFG 7.5 वरला HFG व्हॅल्यू
709.3. 709.3.
ते सांगा
709.
ते पूर्ण कॅल्क्युलेशन नको मला. इथे किती पाहिजे तुम्हाला?
709.3.
709.6. ओके. प्लस आता इथली व्हॅल्यू चुकली का?
0.3.
किती येते व्हॅल्यू?
2055.
20 फायनान्स 2055.
55.85.
ओके. 0.85 आणि फायनल आन्सर किती येते मग ह्याचं उत्तर?
2724.03. 2724.03.
2724.03. गुड, थँक्यू. दिस व्हॅल्यू HW करेक्ट ना? HW करेक्ट ना?
Yes, sir.
Okay. So ME is equal to 5400 divided by 670. The value answer is what? Anybody? किती येते? 5400. हा?
8.05.
8.05. Okay, so is equal to 8.05. Okay, into HS is how much here? 2724.03 minus 173.7 divided by 2257. What is the answer now? Will tell. 9.09. Rakesh, shall I correct?
Yes, sir. 9.0.
Yes, sir.
9.09.
9.09.
Huh? I will write here. If you are little bit near our answer, don't worry. So kg of team, answer will be kg of team. Kg of team divided by kg of coal. Okay. Then factor of evaporation. I will write here Fe. Factor of evaporation is equal to formula is HS minus HW divided by 2257. Now what is this value? Okay, Raki 1.12. So put the value of HS HW and divide by okay, no unit. And next parameter is eta boiler efficiency. Eta boiler efficiency. What is formula? ME will tell ME into bracket HS minus HW divided by calorific value. Now everything is knowing and efficiency is coming as 66%. I want everybody should solve this problem and then write your answer. Then we'll proceed for next numerical. So Rakesh brother answers I have taken in my numerical. Is it correct or anybody want give another answer or majority carries the point? Rakesh brother's answer I have taken in my sheet. Okay, Prathamesh Patil correct all good. Prathamesh Patil correct all good. Anybody is supporting Rakesh, supporting Prathamesh Patil? Solid so that we'll go for the next numerical. Chaneshwar Misra, yes. Okay. Matching. Chaneshwar Misra is also there with them. Kunal, काय चुकला हो तुम्ही? सुहास, कुणाल, गौरव,
सर
शुभम सिंगन, बरोबर आहे ना? थोडं सोपं आहे. स्टीम टेबल समजलं, फॉर्म्युला समजलं की समजते. वास नसते, येस. मॅचिंग ओके. शुभम सिंगन, येस सर, गुड. Shivani Nane also good. Shivani Nane, good, yes. Pramod Avlekar, yes, sir. Very good. Shall I go to next numerical, last numerical of today's exercise? And we'll close today's. So practice much more numerical. Maybe superheated steam only. How to use the steam table and formulae. If you know, then solving numericals on boilers, vapor power cycle, nothing is required. Only formulae, definitions, okay, and then afterwards use how to extract data from stream table. If we know formula, we know, and if you are not making mistakes, definitely will score good marks. Shall we go to next numerical? Or I have to, you. So this is a numerical. Okay. M A is coming as ME is coming as 8.05 5400 divided by 670 kg of steam divided by kg of fuel. Equivalent evaporation formula ME into bracket HS minus HW divided by 2257. Then if you put all the values, HS is wet steam, HW is feed water temperature, HW is equal to HF at 41.5 degrees Celsius, and HMA we got it as 9.09, FE factor of evaporation 1.12, and boiler efficiency 60%. Okay. Is numerically visible? Yes. Then solve now this numerical. I will not interfere now because everybody is knowing how to formulate. Everybody knowing how to extract data from steam table. What is boiler is working at a pressure of 20 bar. Boiler is working at a pressure of 20 bar and produces steam having temperature produces steam having temperature 250 degrees Celsius. हे न्यूमेरिकल परीक्षेला पडलेले बरं का 2-3दा. Produces the steam having temperature 250 degrees Celsius. It generates steam at the rate of 640 kg per hour. At the rate of 640 kg per hour, and consumes coal at the rate of 80 kg per hour. If calorific value of coal is 31,400 kilojoule per kg, and temperature of feed water is 60 degrees Celsius, calculate boiler efficiency, equivalent evaporation, and factor of evaporation. The numerical may have asked for 4 to 5 marks, and appeared for, I think, 2 to 3 times. Okay, without my help you can solve. Write in message box yes, no, काय असेल ते, किंवा my help is, your help is required. Pramod Avlikar, yes. Rahul Chaudhary, yes. Good, very good. So without my help solve. Now steam is wet or
Dry
what?
steam.
Kunal, steam is?
Dry, sir. Dry steam.
Steam is?
Dry.
Superheated.
Superheated. Why superheated? Because if temperature and pressure of steam is given, then steam is generally superheated. But we have to confirm it from steam table. Means 20 bar saturation temperature we have to record, and if it is less than this temperature, given temperature, then steam will be superheated. So Suhas got HS is equal to H soup. Okay. Okay, what is given now? First I will record. So फास्ट कोण सांगते मला पटपट, कोण पटापट, कोण काय काय दिलंय ते? सुहास सांगा पटापट.
Pressure is equal to 20 bar.
So pressure is given as 20 bar. Fast, 20 bar.
Temperature of steam is 250 degrees Celsius.
So temperature of steam, now feed water is different, and T steam I will write here. T steam
250 degrees Celsius.
is how much?
250.
250. Okay. Then what is given next?
MS
Feed
is
water
equal to
temperature is
6.
given. Feed water.
Tea filled water 60 degrees Celsius.
$60. Celsius. Okay. Then pressure 20 bars,
MS,
steam 20. Again, what is given?
MS is equal to 640 kilojoule kg per hour. MS is
MS
equal
is
to
equal to
640
640 kg per hour.
kg per hour. MF is
MF
equal to
80.
80 kg per hour. CV is equal to
Huh?
CV is equal to 31,400.
CV is equal to 31,400
kilojoule per kg.
kilojoule per kg. Anything more than this given? Not, na?
No.
So ME is equal to, first of all answer is what? ME, evaporative capacity. किती येणार? 640 divided by 80 is equal to 8. You write down 8 kg of steam divided by kg of fuel, because I need a lot of time. Then MA, equivalent evaporation, is equal to ME into bracket HS minus HW divided by 2257. Okay, now HS is equal to, काय सांगते, कोण सांगते H is equal to? Who will tell? H is equal to, Kunal got answers, good. Equivalent evaporation 9.39
2902.4.
1.17. H is equal to H soup, because
29
the table number, which table number is there? Table number
4.
Table number 4. So there is temperature is, steam temperature is 250 and pressure is 20 bar. Okay, and there what will you go for value? What is, who will take value? कोणतं सांगत होता आता?
2902.
2902. हाँ.
0.4.
Okay. 0.4. This is table number 4. Temperature is 250 and pressure is 20 bar. Okay, HS is equal to 2902.4 kilojoule per kg. Then HW is equal to HF सगळे न्यूमेरिकल सेम असतील, फक्त टेबल स्टीमची क्वालिटी काय ठिकाणी वेट देतील, काय ठिकाणी ड्राय देतील, काय ठिकाणी सुपरहीट देतील. HF at
251.1.
1 मिनिट 60 degree Celsius and HW is equal to what value? 250
251.1.
251.1 kilojoule per kg. Okay. Then put the value in this equation and we got equivalent evaporation MA is equal to MA is equal to What is the value? 9.39. 9.39 kg of steam divided by kg of fuel. Getting, so all factor of evaporation, Fe I will write. It is 1.174. ओके इथे युनिट काय असणार काय ना kg of steam divided by kg of fuel, no unit, and beta boiler boiler is equal to me into bracket hs minus hw divided by L drop value cv is coming as 67.5%. Hello. Roll number 1 to 10. Unmute.
Roll number 1 present, sir.
Roll number
Roll
1
number
present.
1
Okay. Roll
present.
number. काय म्हणते? हॅलो.
काय नाही सर. नो सर.
रोल नंबर 2. Roll number 1 present, 2 absent. 3, 4, 5, 6, 7, 8, 9, 10, 11 to 20. Unmute.
11 present.
11 present, 12 absent.
13 present.
14, 13 present, 14, 15, 16,
17 present. 17 present.
18,
18 present, sir.
19, 20, 17, 18,
18 present, sir. 18. 18 present, sir.
18 present, 19, 20, 21, 21 to 30, 32 present, 33, 23, 24, 25, 26,
27 present, sir.
28,
28 present.
29,
20.
28 present, 29,
30 present.
31 to 40,
30 present.
30 present, 31, 32, 33, 34,
34
35,
present, sir.
34 present,
35, yes, sir.
35
35, yes,
present,
sir.
37.
37, 38, 38, 39, 40,
40 present.
41, 50,
40 present, sir.
50, 41,
14 present.
42 present, 43, 40 present, okay. 43,
42 present, sir.
43, 40 present, 41 present, okay. 42 present, 43, 44, 44, 45, 46, 47,
47, yes, sir. 47.
41 present, 48,
48 present, sir.
49,
48 present, sir.
48 present, 47 present, 49, 50, 51 to 50, 60, unmute. 51, 51, absent, 52, absent, 53, absent,
53 present, sir.
53 present, 54, absent, 55, 56, 57 present, 58 absent, 58,
59, sir.
present, 58 present, 59,
59 present, sir.
60, 60, 61,
Yes, sir. Present 61.
61 present, okay, Gaurav. 62, 63.
Present, sir.
Okay, 63 present. 64. 64
65.
present. 66. 67 present. 68.
Yes, sir.
68.
Yes, sir. 68. Yes, sir.
68. Okay. 68. Okay. 69. 70. 71. 72. 73. 74. 75. 76. 77. Okay. Anybody remained?
Sir, roll number 19.
Huh?
19, sir, 19.
19. Backward. What are present?
सर प्रेझेंट वेळेलाच अचानक कॉल आला त्यामुळे आपोआपच बाहेर पडलो.
बरं ठीक. कुठल्याच नंबर ठीक. बॅकवर्ड प्रेझेंट होते. बाकीचे कोण अजून? Then solve numerical and next time I will take some test, some numericals on steam table and boiler. Will combiningly will take one test for 1 hour and 1 hour lecture. Shall we stop today's lecture with your permission?
Yes, sir.
Yes, sir.
Shall we stop?